Now that we know about the mole, we're going to look at quantities in chemical reactions. And so back to our chemical equations, remember these numbers in front are called the coefficients. And the coefficients tell us the amounts of reactants and products that are involved in a chemical reaction. So stoichiometry, when you do calculations involving the amounts in a reaction, stoichiometry is going to involve using those coefficients. Now before, when we used those coefficients, we said that they told the number of molecules in the reaction. But really they're just the ratio of the molecules in the reaction. We could be talking about 10 molecules plus 30 molecules yields 20 molecules, something like that. That allows us to use anything that counts the number of molecules with those ratios. In other words, we can read those off in terms of moles. So I could say 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of, this is ammonia. Okay, so we can read those off in moles or molecules, but could we say that 1 gram of nitrogen combines with 3 grams of hydrogen? No. It only works for things that measure the number of molecules, not the mass, because you know different molecules have different masses. Oops. Okay, so know that you can't use, it's not a gram to gram ratio, it's a number of particle ratio. Okay, so this gives us a new conversion factor. If we are looking at a reaction like this one, where we want to say the amounts involved in the reaction, the relationship between the moles of A used versus the moles of B used is given by the coefficients. And so this one is 1 to 1, but whatever those coefficients are. So that's how we convert between moles of one thing and moles of another. And by the way, this works the same way if you're talking about the product. So I could compare reactant to product, reactant to reactant, and so on, any of those. So that's our new conversion factor. And then we also have a conversion factor already to go between moles of one substance and grams of that same substance, and that is the molar mass. And of course we could do the same thing on this side for B. So a common thing to do is to start with the grams of a reactant and then use the molar mass to go to moles. And then once you get to moles of A, you can go to any other compound up there. I could go to moles of B, I could go to moles of C if I wanted to, using the coefficients. And then once I have moles of the substance I'm interested in, I can go ahead and convert that to grams of that substance using the molar mass. So this gives us a lot of possibilities, and this is kind of a map of how you get from one thing to another.